really focus on certain aspects of how things are going to look into. And then the content that I'm going to cover as part of today's session is this. First, I'll take you through to the journey of some of the trends and the landscape in data science and AI. And then second, followed by some of the ingredients needed for success in this field. And third, I'll also focus and highlight on how to accelerate the journey in this space. And then fourth, pick up a point on responsible AI, which is extremely important, very critical in today's business. And we'll talk about a little bit about responsible AI, and then that's just one area in the whole gamut of different areas that we know we are going to talk about in the trends that you'll notice. So I think what I'm expecting is the target audience would be mostly it would be relevant for somebody who's into the student career in the college with some internship experience, understands some of the programming aspects like Python, understanding about machine learning concepts, some of the things about data science that would be very apt. That's one. Second, if you are into a professional, start of your career, it would be for you as well. And then third, somebody who's into 2 to 3 years down the line in the professional journey, and you want to see how you can accelerate your career, it would be apt for them as well. And of course, to the another fourth category where you would be in the corporate for a little more than 10 plus years, and then focusing on what are the key aspects you want to transition into your field to the data analytics or data science and AI field, or how you can leverage some of these learnings to transition to that career. So it could be for any one of you, if you fall into that target audience, is what it will be catering to, right? So without much ado, let me start getting on to the first one, which is about current trends and landscape. Now, when we start with this, right? I mean, we will have to look into what is the business, what is the worldwide AI outlook that it looks when we talk about different aspects of numbers, right? If we look at IDC report by 2021. It says, if you look at this next 3 to 4 years of report, there's a tremendous focus on AI software platforms, AI applications, how they're growing. And if you look at it, the AI market is going to grow, pretty much $500 billion. That's $550+ billion. And it's growing at a rate of 16 to 17%. No brainer on that. So obviously, there's a huge amount of potential in this particular field, how this is progressing across, right? That's one. And if you look at some of the pointers IDC has specified, is about core machine learning, which is traditional machine learning. There's a lot of talks about the conversational AIs, where it deals with your text, voice, a lot of these interactions, chatbots and others. There's also a focus on the computer vision AI capabilities. It's really gaining momentum these days. Then also the explainability and interpretability aspect of it. So if we look at net, there's a huge focus on the entire worldwide AI forecast, if you look at it from some of these points. If we also start looking into the Gartner hype cycle, right? One, we would look at the emerging technologies, and then we'll come back to the AI specific hype cycle. Now, this is a tremendous way to focus and give you a context of how things move. If we really look at the pulse of how Gartner predicts in a futuristic approach, and this has been going on for the last several years. So if we look at the emerging technologies, there are a lot of things to pick up and understand there. One, we look at how some of the things are innovating the trigger cycle. And then second, who are really getting into the peak of the current expectations, and then something which is also getting matured into the process. So if you look at some of the things, you would see something like responsible AI, explainable AI, those are making there. Then there's, of course, different aspects of generative AI, your adaptive ML, which is adaptive machine learning. Then you have the generative adversarial networks. So a lot of these things are part of the IML spectrum, and you will see how these things are moving on. There's also a very interesting way to look into some of the aspects of secure access service edge, the social distancing technologies. Definitely because of the COVID era, a lot of these things are getting importance and then getting into the limelight. And then when you look into all of these things, the way they're moving on, there's some of the aspects which is either going to be the next 2 to 5 years, or currently in the gearing up stage, and then some little later in the future, right? So it's always important to look into and then thought about, how are these technologies going to impact in business across various industries, across whatever we are doing, and try to see what are the pathways of this, and then we prepare ourselves towards that, right? And then on the right hand side, when you look into the artificial intelligence related hype curve, and then there you would see there is something called as small data. I'll come back to it. There's a slide later where we highlight, what that is. And then, of course, a lot of other aspects on the knowledge graphs, the intelligent applications, and then so on, right? And then, as you would see, machine learning, chatbots, computer vision, slowly getting matured into the entire spectrum of the way things are moving on. So what we looked into is the IDC report and the Gartner report. I would always encourage you to, keep looking into some of these analyst forum reports to understand, or at least look at the flavor of the way the business is heading towards, where these technical advancements are creating an impact, creating a value to what these are folding across, right? Now, moving on, here is a kind of a quick summed up view of the trends that I see is shaping up. So you'd see something about the responsible AI, which we'll talk about it in depth. There is also something about AutoML. There is something related to a rise of the augmented consumer, and this is very interesting. We have a slide. We'll talk about detail. Most of it we'll talk about a slider in the detail. But I just wanted to request you to have a look at these and then try to see or foresee into the future how some of these technologies or technological advancements are creating impact or will create significant impact down the line in the futures to come, where there's already been, in different spectrum of things that we are looking into, right? And then more important aspect when we look at on the data science, it's fairly vast. As if you are into it, you would start looking at it. It's an ocean in itself. So there's a lot of area to look into it. It's very important that we understand what's happening, what is the depth of a particular area that we are into, and then start understanding and going in that direction. So overall, net, I think some of these things would create a huge impact, already creating impact in the last few years, and are going to be creating significant impact in the business, where data science and AI play a role, right? Okay, so I'll touch upon some of those that I mentioned about in the previous slide. The first one being this, you have been talking and then listening to a lot of folks probably in the last few quarters, years about big data. Gartner predicts that 70% of the organizations will shift their focus from big data to small and wide data, right? So what are small and wide data? Small data is more about businesses are realizing the understanding of where the practical data sets belong to. We don't need a huge amount of data sets to be able to understand what is what. It is very important to understand the value from the data relevancy standpoint, because when we are looking at 100,000 records, 200,000 records, 1 million records, now first of all the question comes to our mind, do we really need that much data? When you are analyzing it, you'd get data from multiple sources, you'll integrate it, you'll amalgamate it, and then perform your analysis for the insights to be generated out of that. But then the important aspect aspect is that do we really need that much amount of data, right? So that there's a greater amount of focus, and this is a very, very key indicator. If you look at Gartner has predicted 70% of the predictions of what the landscape of the data source systems and then how the data is going to be treated. What they're saying is, the next 3 to 4 years down the line by 2025, 70% of the organizations will move towards or shift their focus from big data to small and wide data. And then small data is obviously in something that we're talking about where it is needed from a data relevancy standpoint. What is more understandable, what is more value from a business context, how it can solve my problems in the business area. That's one where I can extract insights out of it. And then second, when you look at the wide data, it's essentially analysis of various type of data, various data sources, various data formats, and you are linking them all together. So for example, you have the tabular data, you have text data, you have image data, you have the files in video formats, audio formats, or different sensor data, different voice, temperature, weather, everything, right? I mean, all of these that you can think of, how can we link those, be it small and large, be it unstructured, structured, how they can be connected, linked, and then we use them for our business purposes. So it's very important to understand that, from big data to small and wide data, that's where the focus is. And this is all way because we also have to understand is when we are performing our analysis to get value, essentially we are answering some questions to the business, because at the end of the stage, what we're doing is we're solving a problem, we are answering few questions. And then when we do that, we really need to understand what is the core focus of the data that is relevant from a business standpoint, right? So that's where this is one key aspect to focus on from a trend perspective. Then the second one is, I think, is a no-brainer if most of you would be pretty much into it or are familiar with it, which is a lot of focus on XOps, or maybe we would specifically call it MLOps, right? There are a lot of other denominations, jargons, coining of words, or whatever you can say, but predominantly it's ML ops, which is more about operationalization of your entire machine learning solution, right? So if you look at data science as a practice, right, it's always follow a standard, structured, crisp DM methodology, cross industry standard process for data mining, right? Starting from your business understanding to data understanding to data preparation or EDA or exploratory data analysis phases, then all the way to your feature engineering aspects, your model development, model evaluation, and model deployment. So the entire process is the standard crisp DM process phases or the life cycle stages. And any organization anywhere in the world, right, they focus on these type of path or some kind of tweaks to this entire crisp DM methodology to be able to perform their end-to-end data science projects or programs that they're running, right? So if you look at that, 3-4 years back, or maybe 4-5 years back, a lot of ways to create machine learning models, and that all started, right? If we look at it, the adoption organization wide, different set of organizations and all. So now I think with last 3-4 years, with a lot of models being built, a lot of experiments being performed, now really last few years, 1 or 2 years, the focus is more about how can we operationalize this entire thing, how can we manage the entire machine learning models, because you may not have just one model, you may have different set of models, you may have different variations within a particular algorithm or model, and then that triggers to maybe 10, 15 plus experiments. So how do we manage that, how do we sustain that entire model management, model development process across the landscape of end-to-end environments? You would have a development environment, a pre-prod or test environment, you would have a production environment, how that can be managed. So if you look at on the top left corner, the typical machine learning pipeline, you have a data pipeline, you have in the dev environment, you perform the build, training of the models, then there's a candidate model or set of models that you have, and then of course when you get onto the pre-prod, you kind of integrate and validate with your model evaluation with your business rules or your business expectations. What is the best one? How is the best way to look at it? And then you promote this to production, which is where you deploy and monitor. Right. So all of these things typically is a machine learning pipeline. Now, when we are talking about ML ops or operationalizing the machine learning development lifecycle, then there are different aspects to look into it, where the data engineers, the ML engineers or ML architects, or your data science practitioners or citizen data scientists, different type of roles exist. So all of these, when you look at it, on the next chart that you look at it here on this would tell you a little more detail about what is needed to be performed in the organize and analyze stage and the deliver phase, right? If you look at it, there's a lot of things that we're talking about in model management systems, where you're talking about model registry, model manifestations, model deployment, model monitoring, a lot of these things, right? So that's the reason ML ops specifically is going to be very, very important. It is already important. And then why? The goal, if you look at it, it achieves efficiencies. We are automating and reducing the manual interventions. We're trying to make the entire thing automated in a fashion that it addresses to the need of business. And then 4 R's is what I call it. One is reliability. The power of your solution in this spectrum is going to be reliable. It's going to be reusable, repeatable, and also reproducible. Because reproducibility is a very, very key aspect in data science, because it's more about an experimentation field. Because you're going to try, it's not going to be same as SDLC or other IT processes or systems. It's different because you have this crispy and very iterative process, very experimentation-led approach, which is why this is another thing which is going to be important, that is MLOps. Then we get on to something called as AutoML. This is also gaining momentum, and this is something called as, if you've heard of it, AutoML obviously can be like a automatic ML. Yes, it's an end-to-end process of applying the machine learning stages in an automated fashion, but there are different ways to do it. And as we have seen the crisp DM pages, it can be applied and used in many multiple steps. It could be in your data preparation phases, which could be data pre-processing. You can automate in there. You can perform feature engineering. You can automate some portion of that as well. You can perform in feature extraction, feature selection, and then all the way to your modeling activities and model evaluation also, right? And then post that, when you refine it, you have your algorithm to be selected in an automated fashion. You are performing your hyperparameter optimization to fine tune your model to the expected accuracy and all things like that, right? So that's all we actually look at AutoML. And here, if you see, there are a lot of lot of players in the market, a lot of products in the market. Whatever I have presented here is non-exhaustive. Obviously, there's a lot many in the list, but these are very prominent ones. And the moment we start getting into it, try to see whose features and functionality, will get a feel of it. How and what is happening. So if you look at it, the auto escalon, probably auto Veka is not mentioned here. That's the oldest when it started, I think, and then auto escalon, and then all of the other products came up into the market. Azure AutoML is from Microsoft, then SageMaker Autopilot is the most recent one, I would say, from AWS for the last 1 or 2 years. Then H2O have their AutoML. They have a driverless AI as well. Then Uber's AutoML tool is Ludwig. And then there are plenty of it, right? So now, what are they trying to accomplish on the top hand side? When you see this, the picture of the chart, that is taken from a capability of Azure as an example, and then you can actually look at similar kind of things everywhere else. When you look at it in the AutoML, what happens? You have the data set, you have your understanding of the metrics or KPIs or optimization metrics. For example, if it's a classification kind of scenario, are you going to look into some of the metrics like your F1 score or precision recall? And then of course, you have some constraints, time per cost, and all of the steps. And then based on all that, then the automated machine learning takes into account all of these and creates a model based on some of these understandings, best practices that are there, right? And when we go a little deeper into it, how it is happening, what is the way of looking at it? It would look into various iterations, various experiments, looking at the features, looking at the algorithm or the method, looking at different parameters, the variation of those those parameters, and then what are the training scores that are there, right? If I pick this feature, this algorithm, this parameter, my training score could be 50%, could be 75%, could be 30%, could be 40%. And then out of 10, 15, 20, n amount of experiments or iterations, I will pick up the top two, top three, or top five, whatever is the business need, is whatever is the context of our need in that particular scenario that we are focusing on. So it's also getting evident because the lot of best practices, lot of processes, lot of understanding is getting mature, and based on that, different organizations are creating different products which will help expedite the entire process of machine learning. You can always do this using your own approach of doing it. At the same time, there are some of these being built as platform, as a product, and then we can leverage it to see, based on the need of the business, based on the time of it, how can we quickly get into this, right? So that's where it's getting eminent. And then there are a few things that if you are looking as a data scientist, obviously it's a good thing to understand what are the products in the spectrum. But at the same point of time in the ecosystem, you also need to go deeper to have the understanding and the concepts, which we'll talk about it, some of the highlights in the later point of the slides. But here in this charts, when you look at AutoML and try to evaluate, try to understand, there are a few factors you need to look into it and see which product is better or doing better than the others from that perspective. One, you have to look into it from a completeness of functionality, right? What it means is, what are the does it provide AutoML capability for all the 4 or 5 layers in the entire machine learning process or ecosystem or the life cycle stage? Which means, let's say product one, it offers a functionality for feature engineering, for EDA, or model development, these three. Okay. Whereas something else would do only the automation of the pre-processing and the feature engineering, right? And then some of the product three could be for feature engineering, EDA, your modeling, model evaluation, everything, right? So that's where the completeness of functionality, that's one aspect. Second is the versatility of machine learning areas. What type of ML areas that it solves? Does it solve regression capabilities, classification related problems, or clustering, or ranking, or recommender systems? These are all different problem types, problem areas, different techniques, right? So does it, and then there are certain tools who can perform a bunch of those or some of those, and then depending on what their capabilities, they're improving as we speak, and adding new functionalities. But that's another thing to look into it. Then of course flexibility, how flexibilities can we use it in what environment, multiple environments, so on. Scalability, does it handle data with 10,000 records, 50,000 records, the volume of the data, or 1 million records? Does it work there? Or multiple kind of use cases and things like that. Then also the transparency and trust, right? If whatever is happening in the AutoML, does it give you a flavor of a pictorial diagram? For example, like on the top of these, let's say we see the user inputs, these are my data sets, this is what I'm selecting on the target metrics, this is my constraints, and then it will give you, this is how the entire blueprint is, right? So understanding that gives us a lot of control. User are knowledgeable to use it with their own brain power. They can tweak it, they can make the decision making better, because we understand what features, what algorithms, what parameters are going on, right? So that kind of thing is around the transparency and trust on this. And then last but not the least, the simple to use aspect. All of these has to happen in a fashion that any product that we build, anything that we try to automate, should be very, very seamless, should be simple to use, and things like that, right? So from that perspective, that's about another area of AutoML. I'll move on to the next one. So then another one is very interesting on the rise of augmented customers and graph analytics, right? I mean, think of this, last few years, you have a lot of these insights, BI reporting, dashboards, a lot of predefined dashboards. This has all been going on, and then the data science era came in, a lot of predictive plus the dynamic insight-driven analysis have been going on. So essentially, what we are seeing also, the way world is moving across, the predefined dashboards will be progressively replaced with a lot of these automated actions that we are doing, a lot of this dynamic conversational user context specific insights that are delivered to you as a user, right? So that's the shift that is happening, and it's happening in a very progressive manner. It's not that it's happening today or it will happen, tomorrow. It has been happening, and there's a maturity that is going on there. But it's really going to say, and then what we're going to see because of that is, if you look at this, chart of AR/VR related spending forecast, right? I just want to put that, that's one of the analysis from Accenture Research, where they're talking about in 2018 to 2023, the CAGR, the compound annual growth rate of how the growth in the consumer spending and then the industry spending that are happening in this area of augmented reality and virtual reality. So that's another area of which is really important. And then there's a lot of augmentation that is happening between AI plus AR/VR. How both as a technology can really help impact some of these. And some of the examples that you would see, if you look at Volkswagen or some of those, the designers at Volkswagen, they can look at this kind of a platform to see how they can get it themselves into some of the virtual worlds, experience the car's look, feel, that is design, 3D, so that the selling experience, the understanding, the experience of the customer coming in becomes much more interactive, intuitive. That's one way of looking at where AR/VR meets AI, and then that kind of a reflection is happening in the outset, right? Then another example is Lowe's. It's a large retail outlet. They are in store. There's something called as virtual reality VR polo room that allows the customers to sample their household products before making an purchase, right? So imagine of a scenario these days, all of you are so familiar with buying something from Flipkart or Amazon or some of these things, the e-commerce sites. It's last 5 to 10 years, it's been becoming a very, very habit. There's a lot of demand is going on. Your product matching. If I've searched on certain things, then how can I better perform that product matching? Now it could be assisted tagging, it could be a product matching. That's where Facebook AI team working on some of the very interesting aspects where based on the user actions, user experiences, these are getting improvised. It's not that it was not happening a few years back. Yes, it was happening, but then the point of focus is how they can refine that much effectively, because a lot of details that is getting in, with our past historical data, a lot of products that we have been searching. We may be searching a lot of things, a lot of categories. How can we get into log in into the next time and then get onto a platform where our matching expectations or recommendations or suggestions from that particular platform is much effective, right? So that's another thing. Then assisted tagging, they're also talking about some places that you have gone through or visited, how it can be tagged with the similar products, kind of association kind of thing, so that you'll get some very context specific experience next time. And there's a lot of similar things that are going on. So that's from a more towards this. And then another example on the relationship between this graph analytics, right? If you start looking at it or Google through it, you'll really understand that the relationship between people, between places, between things, between events, locations, all different diverse data sets. There's a demand. How can we collate all of these? LinkedIn does it in their domain on various interactions. Some of the other organizations perform similar things. There are social networks, there are other groups, there are other different type of paths, locations. So there is a tremendous focus on that coming in, because interaction analytics is what I would say, or the graph analytics, right? Is actually propelling that all things to happen, right? So one is about this augmented reality, is the technology that's enriching this entire digital media and things around that. Second is about this computerized graphics, the virtual objects, which are being used in real-time scenes to create an impact. And then third is about this graph technologies, which if you go by the Gartner's prediction, they say graph technologies are expected to be used in 80% of the data analytics innovations by 2025. So in the next 3 to 4 years of the timeline, it's going to really gear up a lot. And then, of course, you see the ARVR spending forecast from Accenture, the way it's been propelling across. right? So the all of these, the focus is, yes, to look into the consumer specific view, consumer specific behavior analysis around that, and then at the same point of time understanding the applied value of all of these in the industry segment. It could be retail, it could be BFS, it could be insurance, it could be manufacturing, it could be oil and gas, it could be any industry for that matter. But very important to understand the business use case sentiment, and then how things are moving, how technological advancements are going on, right? So moving on to the next, and that brings me to here where I'm kind of correlating. If you look at this analysis from McKinsey report, it focuses on the technical, the relevance of various, I would say, data science techniques or methods or algorithms in the area of that, and then how the relevance of it from a technique standpoint by industry, right? So if you look at this, some of the interesting aspects is, yes, pretty much all of these, if you look at on the left hand side, there's the high end deep learning or some of those algorithms or methods like your feed forward networks, your recurrent neural networks, your CNNs, your GANs, generative adversarial networks, reinforcement learning. So there is a focus on that. And then, of course, on the right hand side, which is not highlighted, if you look at where your traditional machine learning or the core machine learning focus areas, right, which is where your regression analysis, your classification or tree-based ensemble learning approaches, or specific classifiers, clustering, or just about the statistical inferences that have been portrayed. So one of the key things that you'd notice here, look at all the industry on the left hand side, right, from banking, agriculture, automobile, retail, everything, right? The business use cases, we see how they are looking at it. The frequency of use from the smaller problem to the larger size of the problem is what has been represented here in this chart, which whatever the survey or analysis McKinsey have done. But very interesting thing to look at it, and which also resonates to what actually happening in the lay of the land, is looking into the regression and then the classification ones, right? Regression analysis or the tree-based ensemble based approaches is being used predominantly in many of the places. They are very stronger. So one key takeaway is that continue to focus a lot of your focus around the regression, classification, clustering, the simple methods which we feel are going to be simple enough to focus on certain aspects of it, and they are driving majority of the use cases today in the industry. At the same point of time, yes, there are a lot of other high-end deep learning methods like feed-forward networks, your RNNs. They're also being getting prominent. Another thing to watch is the reinforcement learning, which is also expected to be used in many industry use cases. If you look at it, their presence is maybe relatively smaller than the regression and the classification areas, but still they have a focus across many industries, and which is what is also gaining momentum. It's in the active research for the last few years. It's been in the applied area. There's a lot of things that have also been used as we speak and as we progress together through the next few years. Then the next one is about something like a representation learning or compute power. Obviously, with the way we are dealing with the data, large volume of data and things like that, there's a tremendous focus on the compute power, right? And then recently, if you have been following some of the various news about what's happening in the area of large data handling things, then OpenAI, which is where they have this the GPT-3, right, which hints at some point of time training 175 billion parameters, which is beyond than any other transformer models like BERT and others that they have mentioned, Robota, BERT and others, right? If you are familiar with those. So which means that there's a lot of use of the compute power is expected, is needed, and that's also more important for a lot of AI problems, and how to handle that effectively is one thing that a lot of focus is going on in that area. The representation learning is or feature learning is nothing but a set of techniques that help you or help the system to automatically discover these representations. If you look at what is feature extraction and feature learning, there's an example of this, when you have a raw data and then you are extracting some features, this is how you'll do it. But the representation is about, if these are the features that I have taken, then what is my right set of features extracted. That is important. And representation learning or feature learning, which is known as more about the right set of features that are extracted and passed on to the algorithm, right? So if you on this smaller chart, if you look at it, whether we talk about a simple mathematical equation like y equal to x plus p, when we represent it on a chart, then how does it reflect? How are we interpreting that from the input query that we have, or the equation that we have? Then similarly, if it's an audio file, then how's the chart or graph is coming across? Then we may have some data related to travel industry that can be put into a tabular format so that we can analyze. So obviously there is one about of representation of these things in terms of features, and that's where it helps us a lot. And then in addition to that, the compute power, both of these are very important in any of the field that within data science that we're talking about, which is going to be very important in the future. There is also something called as very interesting multimodal machine learning, which is where you might be really looking at a lot of things happening on the audio data, the visual data, the images, but with the help of representation and alignment of that, and how can the multimodal representation be constituted, right? How can, when we look at different type of things, right? The visualization, the objects that we see, or sounds that we hear in terms of the audio files, or some of the sense, or the odors that we smell, or a lot of these things, right, in our surroundings. When we combine that, is there a way that we can get those amalgamated in a place that we can drive information from that spectrum, right? There's a lot of research going on in that, which is where if you look at it, there's a visual, there's a verbal, and then the combination of that in a multimodal representation of that analysis being done. There are a lot of papers, a lot of research happening in the image captioning side, audiovisual emotion recognition related areas, audiovisual speech recognition related areas. And of course, you would be seeing the output as some of the products that are getting more smarter, right? Whether it's Alexa or Siri or others. And then a lot of these things that are going on in the NLP related field, how can we look into the NER, SNM entity recognitions, and then things like that, right? So that's also another area that's focusing a lot. Then another aspect is about the responsible AI getting onto it, which is really important for adoption of AI. And there should be a clear focus of why it is happening. We'll talk about a little later about little more detail about this one I picked up, because I felt this is really important for us to first of all understand it. If you're not familiar with responsibility AI, if you're already familiar with it, then of course you would know some of these and would be able to appreciate this much better. But on this chart, if you spend some time to look into it, or research through, there's a professor Basanthar who's in New York Stone University, and he's has written some of his point of views in HBR. When we look at it, it's a very interesting way of putting together something called as decision automation map, which he calls, right? DAM, decision automation map of the future. And then if you look at in this, on the x-axis, he has plotted like predictability from low to high. On the y-axis, the costs per mistake acceptable from a predictability perspective and the cost per mistake perspective, and then try to put together some of the use cases, right? So if you look at online advertising or high frequency trading, these are something which have predictability on slightly on the lower side. And then also the cost per mistake is also not much, right? If you have some incorrect predictions, then it's not going to cost you much. Whereas if you're analyzing on something related to, let's say, diabetes prediction, or fighter drones related analysis, or driverless cars, right? These use cases, then of course we understand the predictability varies, and then the cost per mistakes is also high, right? So we have to really look at some of the different type of use cases, how the predictability and cost per missing, that is actually triggering to how can we understand what is happening within a model, what is the explainability, what is the interpretability, how do we trust the machine learning solution that we are building. And then that's where everybody is focusing a lot on the ethically responsible solutions. And then if you look at smarter, responsible, or scalable AI, it can only happen or exist if you're able to get into the details and explain why it is happening, what is happening, why it is happening. That's one. And then of course it's a lot of other aspects, right? It's very fair solution, the fairness, and there's no bias about it. You look at the robustness aspect of it, the data privacy aspect of it, and a lot of these things. We'll touch about this in detail, so I'll just not focus too deep on this slide itself, but I just want to highlight the point of the trustworthy related AI solutions, more resilient AI solutions, and how do we understand the importance of responsible AI in some of these use cases that we are looking into, right? So I think that's pretty much it. So if I sum it up, yes, some of the things that we touched upon on the trends, what's happening around data science and AI. We need to understand what's happening around in different areas, why it is happening, and so on. So that would give us a reflection. Then on the second part, I'll try to focus on the ingredients needed for success, right? And this is something where I kind of coined my way of IQ of AI: inspire, innovate, and interpret, right? And what I meant by inspire, if you look at the first I of it, is there are a few aspects, and this is very important, right? Our motivation should always be driven by use cases or the business use cases, because we may be knowing the technical aspects well or trying to understand what's happening, but it's very important that we correlate the business use cases. What is the business objective? And then from a business problem, you start getting onto a data problem. That's where it's all said and done. It's very easy to say that yes, the industry knowledge, domain knowledge is important, but when rubber hits the road, when we actually start getting into it, there's a lot of um, difficulties, complex aspects. So that part is very important, and we should look at that should inspire us. That's number one, right? Second, you would have seen some of the trends and all the importance of core and traditional machine learning solutions are very important. Any solution that we solve, it's very important to look at the simplicity aspect of it. The core and traditional machine learning solutions are important rather than the complex ones. Yes, some of the cases, you have to go to the complex ones, but before targeting that, it is very important to focus on core and traditional solutions first, and then move on, right? So that's another second aspect. Then you should also have looking at inspiration by specialization and interest level, because there are a lot of subcategories within data science. It could be computer vision, it could be natural language processing, it could be reinforcement learning, it could be multimodal machine learning, it could be AutoML and other EDA related stuff, it could be your data visualization aspect. There could be different areas, but we should really pick up one or two areas that we want to focus on and specialize and move there. And then always we need to have that problem solving attitude, right? Because essentially we're solving a problem. We are, with the help of AI, with the help of some of these methods and algorithms. So if we identify the problem, if we know the process to think, then that's where we'll be able to add more value there, right? And then second, when we get onto the second pillar of innovate, obviously, data science and innovation go hand in hand. We need to look at the novelty of the solution that we're building, how novel it is, the non-obviousness aspect of it, the usability and the value in the industry. Obviously, we're going to build something which is usable, which somebody else can replicate and things like that. And there is always going to be research and innovation focus, right? That's also important. And yes, as I said, innovation across problem types. You should look at what type of problem that you are trying to innovate. Is it more about descriptive side? Is it predictive? Is it optimization? That part is also very important to focus on, right? And then the third, which is also the important aspect of I, is interpretation or interpret, right? Where any output that you generate or build, the interpretation of the output is very important. And then that's where you start building your storytelling ability based on that. And then you can do that in your data visualization or EDA steps. You can do it in feature engineering steps. You can do it in model development or algorithm selection, algorithm analysis. That area you can do it in all the stages, right, till continuous optimization and things like that, right? So that's the three I would call it I cube of AI, which is very important in this journey, right? Then getting on to the third part of it, which is how do you accelerate the journey, right? What are the key points to focus on? So we'll look into first, it's very, very important about math behind machine learning. Because when we start understanding some of the problems and try to solve, it's always in a hurry, we'll jump onto it. It's very important we look into the probability, the conceptual things about probability, the statistics, linear algebra. All of these are extremely important and the foundations of it. If you're really not understanding some of these things and the math behind it, it's going to be very difficult down the line to figure it out. What algorithm, why are we using it? Because at the same point, as you would have seen in the previous slide, the interpretation is very important. And if I know how it is happening, what is the math behind it, at the end of the day, I'm solving an equation, whether it is y equal to mx plus c, as simple as that, or some complex form of the equation, right? So either I'm optimizing it, or I'm refining to a particular problem solving type, or something else. So it's very important to focus on some of these, and I'm sure that there are a lot of focus points, materials, learnings that we have around it, but it's very important that we stay focused. And this aspect of math behind machine learning is extremely critical, and that's one of the key points. Then the second one is about in-depth analysis and holistic approach. When you are building your projects, your proof of concepts or proof of value, you'll have to look at it, how in-depth analysis that you can perform. What is the holistic approach that you're taking, not just from one piece of entire end-to-end flow, but are you looking into the business statements, business goals, then your data understanding part of it, then your feature engineering steps, why you are picking up those features. And within that also, there are a lot of different aspects. When you are performing your data understanding or ETA, you'll have to look at how do you handle the missing values, how do you handle the outliers. All of that are again dependent on various tricks and traits, depending on the data context, depending on the problem that we are solving, depending on the project at hand that we have. And there could be assumptions, there could be constraints. So we have to look at all of that. But our overall view has to be in-depth analysis on a particular thing that we are doing, and holistic approach that we should have, right? Then the third aspect is also about the industry-centric use cases or applied AI, because at the end of the day, you are solving a problem. We have already talked about this in some of our previous slides, the emphasis on specific kind of use cases by industry. If you are focusing on manufacturing, you should understand, what are the different areas of use case themes that are more relevant in this industry. And then how you can do that, you'll have to go deeper into different subject within that industry, right? If it could be different process one, process two, process three, and within that, where AI/ML can play a role. And then that is extremely important, because whether it's a predictive maintenance use case or a yield optimization use case, or supply chain analytics or logistic management, warehouse optimization, it could be anything in that paper. But it's very important to understand that particular industry, some of the sub areas, and where it gets into it. So for example, if you look at banking and financial services, you have the customer analytics, you have risk and regulatory analytics, you have marketing analytics, you have operations analytics. There are different aspects of it. When we look at a customer churn, customer segmentation, next best offer, next best product recommendations, different type of customer behavior analysis, all of these things has to be related to a particular industry subsegment. And then understanding the use cases, or defining those use cases, are going to be very, very important in our overall journey, right? Then only we'll be able to approach the problem better. Then the last but not the least is focusing on, this is also very important, about the community presence on visibility, right? If you look at one is about GitHub, maintaining a GitHub profile, and having that is extremely important, because today what's happening is, whether somebody is having 0 to 5 years experience, or 15 years experience, or 30 years experience, you need to have a GitHub presence. You need to have, whether you are a research scientist, research area focused roles, or whether it is applied data scientist kind of roles, or whether it's data analyst kind of roles. It's very important. Either we are associated with somewhere or the other, with our enterprise GitHub, and also we have some personal GitHub that we focus on. So that's one. Second, LinkedIn is extremely powerful. Please make sure you have a stronger focus and then there, the completeness of a lot of those stuff that are available there. Then some of the forums like Stack Overflow, I mean, that's Google, and Stack Overflow is our the ingredients for us to propel to the next step, right? I mean, and then of course some of the the community forums like Kaggle, where it has 1 million plus data science users, and then of course a lot of these, whether it's BitGrade or Analytics Vidya or some of the other, just a few of the representations here, but just to make sure you focus on some of these, so that whether it is a competition, whether it's a hackathon, whether it's a competition coding related activity, whether it's a timed activity of 2 days, 24 hours, or 1 month, 2 month, that could be potential thing. Then there is other thing, when if you look at Kaggle, right, there's a lot to learn in the data sets, in the notebooks or kernels, in the discussion forum. So it's all about giving that community presence, visibility. And then when you move on to a thought leadership level, then obviously the focus is on writing some blogs. It could be based on your point of views, it could be based on your projects and things like that. You want to articulate what you have done better, what are the best practices, what are the lessons learned. So something like Medium and all are great forums to have your blogs or stuff like that, right? So these are all some of the key points for acceleration in your career in this field. Then we move on to the fourth one, which is about responsible AI. Um, Now, when we look at responsible AI, of course, you have seen what we were talking about. It is essentially, it's just an example of few stuff, whether it's, what has happened in the last 2, 3 years or last 1 year and things like that, where we're talking about why, we're going to trust the algorithms. Are they biased? There are some of the cases, like examples in the loan approval case. Why would it be biased to create a solution which will approve for some X segment and would not approve for some Y segment? A lot of these things we have seen in the past, and that's where the need for relatively fair usage of AI model is coming up. And then that essentially would mean that we build some solutions that impact more responsible way of the business outcomes. And that is very important. More responsible way of business outcomes. That's what we want, because we just don't want to create something which may have some adversities in future, right? We just want to look into which creates a solution which will impact in a more positive manner, more responsible manner, and we should be able to answerable in some of the outcomes that the model is building. And that's the need that is coming up. Then the definition, if you look at by the wiki definition, this is the ethical AI definition that they say, and then I'm not going to read there for you. You can always read through this. But one of the core pillars, if we look at, are one is about fairness and avoiding bias, right, in your solution. Then second is about explainability or interpretability, extremely important in the context of responsible AI. There's also robustness. If you're building something, how scalability is, how robust it is, that's also have to look into. And then, of course, there is privacy and security is another pillar, and also the trust and transparency that will come from all of these, taken together, right? And if you look at, there's a reference from PwC research where they have also taken some sample surveys across the CXO communities and others. And then what we see based on their analysis of research is organizations globally are recognizing the need for it, and how they're doing it. If you look at these numbers, that will tell you the story, right? 64% boost AI security with validation, monitoring, and verification, and all of these. And only 3% feel that they don't have any plans to address those AI issues. So which means 97% really focus on trying to get a solution which is more responsible and things like that, right? So that tells the story of the importance of it, the need of the responsible AI. Then moving on to, then how do we handle the risk by crisp PM phases, starting from conceptualization to data management to data development or the model development. Then, of course, the model implementation and, model decision making from the model usage standpoint. There could be a lot of potential issues that can occur in each of these stages. And that's we have to really look into, ask ourselves the question, do we have incomplete data? Because if we are analyzing on something, if I take example of this point, if we have incomplete data or inaccurate data, does it throw something which is not appropriate? Does it show something which is not correct? Now that's important. So we have to go back and fix, yes, we need to data from the correct sources. We need to have relevant data that are considered for our analysis standpoint, right? And then a lot of other things that you see, and I'm not going to touch upon all of these, but this is just a reflection of how you can look into and handle the risk by the CRISP DM phases when we look on. And this is another way to look into the 10 key checklist points. There could be many more, but some of the focus points. And here is a replication of crisp DM stages or life cycle stages that have been represented. And some of the key questions that we ask as a checklist to us, are we doing this or not? So for business understanding, if you look at, is an algorithm an ethical solution to the problem? If it is not, should we look at some other algorithm, some other method? How are we solving it? Why do we need a complex problem if it is not needed at all from a business perspective, right? And what is our business goal? Are we adhering to that and creating our solutions on top of it, right? So that's one major point. And then you go to data understanding, then you'll see, do we have fair data representation, which is what I was talking about, the data relevancy, the effective content of the data, which will give you required number of parameters, because at the end of the day, what are you trying to achieve is going to create a kind of a solution based on these parameters. These are your independent parameters or features based on which you try to look for the correlation of your target variable. How does it influence the target variable, and so on. So that's very important, right? Then data preparation, a lot of these things are there, biases and levels or features that we can potentially, if we know, can be rectified, so that down the line, our next set of process would be much more efficient, much more intelligent, right? And so on, modeling, evaluation, deployment, and then of course, the human in the loop, HITL, right? It's always going back and forth to see that does the model encourage the feedback loops, because essentially, if you are building a solution, it's very important to get a review, get a feedback, right? If we do that, then does it perform in a better manner, and so on, right? So those are some of the 10 checklist items that we can think from that perspective. Now, there are also, these are some of the things that you can look at it. There's something called as the Ethical Institute. If you go there, then they focus on some 8 principles. One is about human augmentation. Then, of course, I'm not going in detail of it. Bias evaluation. You can always refer to the deck later. Then, of course, some of these things, explainability by justification, your reproducible operations in the sense, the reproducibility aspect is very important, right? Are we setting up an infrastructure to enable a more reasonable level of reproducibility of the ML solutions, right? That's very important, right? So then all of these 8 principles, if you look at, it gives you a reflection of what we see, what we think, and how those are dependent on the responsible AI from that perspective. And that's where, if you look at the Ethical Institute, they've been a firm analyzing, researching, and working on some of these. They've defined some of these 8 principles, which looks very, very eminent. And then let me focus on the explainability and give you some examples from this. So if you look at the explainability or interpretability, it's a black box to white box. How can we perform something so that we can know what's there in the black box, right? That's the intent that we're trying to do. So how do we build trust in our ML models? How do we know what is happening as part of the ML process? If you look at it, your X1 to Xn, your independent variables, you have a black box model, and then you have a target or y hat, right? And then some metric evaluation is happening. Now, interpretation will give you some analysis or interpreting abilities from that black box, which is what we're talking about, more focus on the explainability side of it. And how can we do that, and why it is needed? Yeah, because of many aspects that we have been talking about. It could be causality of features. It could be ability to debug and know some more details. There could be regulatory requirements as well. Of course, the bias, ethics, and fairness, that's important, trust and understanding. And also to look at the critical domain and industry need. There could be many more other industries, but if you look at finance, if you look at healthcare, if you look at risk or judicial, that's where this becomes much more important, because the kind of use cases that you deal with and we try to solve using machine learning and deep learning methods is important, because they are solving some of very critical decision-making steps with the help of ML. So you should be able to define why or explain why this is behaving this way, or why it has predicted this way, right? Then another point of thing is, do we need interpretability all the time? Answer may not be yes, we may not need it all the time. So there are two examples here. One, if you look at a situation which is kind of a end customer call service team that are interacting with a call resulted in a dissatisfied customer. Now they are good to go as long as they're getting good performance on this from the solution. It is solving their purpose. It may not impact too much to the end customer from that aspect. That's one example. Another example could be, when you are looking at a well-studied article, and then there's an optical character recognition stuff that's going on, OCR kind of analysis. Now, for OCR type of cases where you can get a lot of training data and can rely on good performance for the task at hand. So if it is predicting something, you have a lot of training data, which may be effective. It may not be the case in other scenarios. So there could be some of these examples where you may not need interpretability also. So that's what we're trying to highlight. And then the framework, if we look at, ideally the framework would be based on by scope and by model type. By scope, you have a global need, you have a local need. And of course, it may be model specific or it may be generic, model agnostic, right? Now, in the global and local need, if you look at, how we are differentiating, in this kind of a scenario, when you look at this and classify, try to use your machine learning, there could be a local interpretation within that segment, and there could be a global interpretation where there are different classes are interacting amongst each other, right? So there are various techniques and libraries. Now, what is presented here is a very non-exhaustive list. There are a lot of things that are being analyzed, but some of the things that if you are new to the field of explainability, you can look at something called as LIME, which is local interpretable model agnostic explanations. There is a Sapely additive explanation, SAPE. There is something called as LE5, explain me like I am 5, and then partial dependence plots also. So I have, kind of put together some high level, definitions and approaches of what they differ and what they look like. All of these are Python libraries that you can leverage and use in your analysis to see how the difference of those things can happen. And when you look at from an accuracy and interpretability perspective, when you go from linear regression to decision trees to, all the way to neural networks, obviously your accuracy would probably may be much higher in neural networks and random forest or boosting based algorithms like XGBoost, CatBoost, and all light GBM and other models. Whereas interpretability, obviously, would be very less in these type of complex models, right? Your interpretability would be much more on the linear regression and simpler models like that, right? So that's another thing to look at it. But at the same point of time, we cannot really say which model is the best model, because we have to look at the data, we have to understand the pattern, we have to understand what we are trying to do as part of that problem solving process, and then only we'll see based on the experimentation which one is better and which one is not, right? So a few examples to look at it. So I've taken an example of LIME. Now, all of you, I mean, if you are, of course, Titanic is a very simple data set. You can, if you're new, then you can try with this, or else you can pick up anything like customer churn or flight fare prediction or some similar data sets also, and then try to see how all of these explainability features are being used with this features and techniques or the packages, right? If we use LIME in this kind of scenario, and I'm assuming most of you would have understanding of the Titanic data set. Now here, obviously, scenario one, you would see the objective is to predict the survivals of the passengers in that particular data set. That's what we're trying to predict. We would predict that as part of our machine learning solution when we do. But after performing all of these, we can use LIME package to understand, for example, in this case, we have taken one particular passenger ID, which is 421, if you look at, and it's actually not survived. And that's what the model is also predicting. But this one, when we look at it, first of all, it's a male passenger with the age of 21, and some of the other attributes like embarked from the city Q, and not survived is what's been kind of predicted as part of the machine learning solution. Now the interpretation is what, model has predicted that this particular passenger will die, because 87% of the prediction says that it will die and 13% only say it will survive. So the key aspect, the biggest aspect is the gender. If you look at from this, since the gender is male, then that has got a huge influence that the passenger will die, right? That's what this particular analysis from the line package that it's significantly demonstrating. Then the next parameter is about the passenger class, which is 3. So if they fall into the class 3, then that also contributes towards decreasing your chances of survival. So if you at the same point of time, if you notice some of the parameters contributing more towards will survive, right, is where the parameters such as age. If your age is less or equal than 22 years, then it will show a very prominent portion of those 13%. It's contributing to the fact that you have some higher chances of survival if your age is less or equal than 22 years in that particular data set what we have considered, for example, right? So what it's doing is, as part of this entire thing, it's giving us a much more introspection into why this is happening, and if it is happening, why it is happening, right? So that's the key thing that's looking at. Similarly, if you go on to another example, you could see the similar type of things. I'm not going through it in detail, but just to give you a reflection of an example and how this happens in the particular Lime package, that's another example of another passenger ID that's demonstrated here. If we take another example of LE5, it's a different package, not Lime, which is more of a local interpretation focus and model agnostic focus. Li5 is where you'd see these other variables in the same Titanic data set, and there are a lot of ways we can understand the feature importance, and we can explain the predictions based on the weightage of each features, how it is behaving and things like that. And this is where we have taken an XGBoost kind of algorithm, which is an ensemble based approach, and but it's a more complex one. It's very difficult to understand what's happening inside this, what are the weightages within this, each and every parameters and features, where using LE5 you can see what are the focus aspects of it. Then you would have some value which is missing, and then you can further use some of the aspects to see those values where it gives you a very proper contribution by features or by features value. And it seems based on these data that it's good to be female, because that's where it's contributing a lot, that you'll be surviving. And also not good to travel in the third class, right? Class 3. If you travel, then there's a larger amount of aspect that you'll do, because it's minus 1.1 is the contribution if you look at in the right side of the table there, right? And whereas the gender part is plus 1.63 or 673, which is contributing to it. So a lot of these things would give a lot of introspection into why the model is behaving this, predicting this. That's where the explainability and interpretability is, right? Then we can also look into another flight fare prediction. You can go to Kaggle and then look into this kind of a data set where you have this. Then you can use something like another package called Shape, right? SHAP, and use this to have your data in a different numerical format. You perform all your EDA and other stuff, and then try to understand the summary plot, which is nothing but the feature importance that it gives. Of course, you can get the feature importance in some of the Gini coefficient and other from random forest models and other stuff. But at the same point of time, this also gives you a reflection of this. In addition to that, it gives some force plots, and force plots is something where it tells you about the traditional variable importance algorithms, how they only show the results across the entire population, but not on each individual. Your local interpretability enables us to pinpoint and contrast the impacts of these factors, right? The base value of 9116 here in the context of this data set means that your y, you have the target value, and how it is shifting to the left or right and things like that, whether it is higher or lower, and those things. Okay. Then again, of course, you can have some summary plots, dependency plots. These are again with this flight fare prediction data set with SHAP, and you can see different. There's a lot of focus if we look at the summary plot, right? There's a features versus the safely values prediction. Feature value on low to high is been represented, and then you have the shape values minus 5,000 to plus 5,000, 10,000, 15,000, whatever, based on that index or window is what it's trying to show you a reflection for all the features, duration of our specific airways, names, journey days, route 2, route 3, and all that stuff, right? That gives you a reflection of that. So in this, if you look at certain features in the chart have flat and wide values, it's like spread across, which is like more maximum minimum importance there. But while others have kind of very value centered above or below the zero, very narrowed down. So that also gives a reflection. So some of these gives a different type of analysis which will enable us to go deeper into the model and understand which variable, which feature is influencing my target the more and most in what way, right? And same is, of course, dependency plots and other stuff. So I'm not going to detail of anything else. So that's all. I think to sum it all up, the core point that I want to message across all of you is the better the interpretability and clarity in model solution, the better is the adoption of data science. Because if you are building a solution, if you can explain it better, if you can interpret it better, then obviously everything will come much stronger, and you will be able to articulate it better, right? So to summarize, what I have covered as part of this is one, I spoke about some of the current trends, landscape in data science and AI, ingredients needed for success. Then third point, I focused on the acceleration in the journey. What are the key points to focus on? And the last one is, I focused more deeper into responsible AI and things around that, right? So that's all have covered for you. I'll be open for questions if any. Thank you so much for patiently listening so far. Let me know if there are any specific questions. Over to you, Baljinder.
Thank you so much, sir. That's an wonderful session and a good one. Drive through that so much knowledge about data and everything. So I have questions for you. I think people just there's some two three corporate people those who just send me direct questions related to. So just give me a second. I'll
Sure.
tell their questions to you. Before that, if anybody else have any questions, please drop your question in the chat box, and we are open for the Q&A session. So, sir, there's a first question from Amandeep. He works in ZS Associates. So he's asking, how do you think the output of the multi-model machine learning can help us?
Sorry, how do you feel the output of what?
Multi-model machine learning can help us.
Okay, very good. Nice question. I think multimodal machine learning is something where we are talking about amalgamation of multiple different sources of data patterns, right? Whether it is audio, video, image, and all of these. Now, we have seen in the past how images, computer vision, how text to speech, speech to text, these conversational AI, these capabilities are impacting the business and business use cases. So when we look at multimodal machine learning from that perspective, I feel there is the world is going towards, how can they combine all of these, because we are talking about touch, sense, essentially data coming from all of different ecosystem. And we are trying to make use of all of that to analyze and produce some of the insights on top of that. So definitely it will be useful. How it will be useful depending on different type of use cases that we deal with, different depends on different type of aspects in various industries that we look at. If you also look at, if I have to look at some of the examples, right? I mean, recently, you would have known Microsoft has been working a lot on this side. They've acquired Nuance AI. There's a lot of focus around expanding their horizon on the text to speech, speech to text, and conversational AI and the image part of the system, and giving all the flavor of it. If you look at a lot of these large cloud enterprise players, right, whether it is AWS SageMaker or Azure ML from Microsoft or GCP or IBM Cloud and others, the focus is all to provide more features, more functionalities, how this can play and get a user experience much better in that direction. So I think that's heading towards a lot of these research innovation in this space. While it is not easy and simple, but there has been a lot of progress. And as we speak, maybe I'm not knowledgeable in too many things that's happening around the globe, but definitely there are a lot of positive aspects going on. And for us, if we want to focus on a certain area, it would be really exciting, because then we have a passion in that area, because we interact with a lot of these things in a day-to-day life, right? Because when we talk about Alexa, Siri, or interactions on this, then or the chatbots, the knowledge extraction, different type of information analysis, we have been dealing that in a day-to-day life. So which we interact, experience in a day-to-day life, we'll be able to correlate and understand that problem better. And if you understand the problem better, then obviously the solutions will automatically come up. So I think, just to sum it up, there could be multiple ways to look into it, but the opportunities are immense.
Nice. Thank you, sir. So there is one question in the chat box from Arshif Mohammed. The question is, so are there any global standard possible for responsible AI?
Yes, absolutely. It's a very good question. I think, as I said, there are a lot of work going on across regions. And see, if you look at the European Union, there is something in the Scotland, a lot of US research. They're all focusing a lot, like the way we have different type of standards that have come off as other cases like HIPAA or GDPR and others. Same way, I think responsible AI is moving in that direction. It may take some time, but as you would have noticed in some of my slides, the ethical AI institute, they have defined some of the principles. If you look at some of the countries, they are doing it. Maybe the next step would be to see whatever is working in Europe, whatever is working in North America, then India, China, they may have their own, and then of course globally there could be some accepted principles. But definitely, some of the things which is really core to everybody's thinking, maybe some of them are talking about different lingo in terms of principles, focus points. But then when it comes to different aspects of it, then they focus on the fairness aspect. They focus on the transparency of what is being done, the clarity of the explainability, interpretability that we spoke about, the focus on how it can also look into the data privacy, data security aspects of it. So these all things are really important and core to whatever everybody is looking at it. But I think, yes, in India also there are a lot of things going on the government side. So there it could be possible that there would be some global defining standards or principles, but the existing one also across various continents, if not countries, are also fairly generic and point towards the similar focus principles, is what I would say.
Thank you, sir. If you open your chat box, there is one more question from Nitin Malik. So it's like,
Okay.
which one of three tools you mentioned is better for model explainability, and what kind of bias mitigation algorithms are used in an industry?
Sorry, say that again. Read that for me, please.
It's which of the three tools you mentioned is better for model explainability?
Okay, so which means these are all packages in Python that I'm referring to. So If you are talking about, okay, what kind of which of the tools mentioned here better for model explainability? Okay, you're referring to Nitin Malik's question,
Yes,
right?
yes, yes.
Okay, all right. So I think there is no one good or the best tool as such. I think Shape and Lime is being used a lot. Shape is used a lot. If you look at it, that those which are used a lot, they probably are, I would say better because the usability is more. Li5 may be very smaller cases that I have seen with my limited knowledge. But all of these, whether we talk about partial dependency plots or Shapely and Lime, are very strong, and we can use them for specific purposes. And each of those would have a purpose of framework that we're talking about, whether it is for local interpretation or global interpretation. How are we dealing with it? It all varies to those type of problem sets also. So if there is a need for local interpretation of the model solution, then yes, our analysis should be towards that. If it is more about something else, we can focus around that. But I think, in my opinion, Shapley and Lime are the ones which is used the most.
Thank you. There is one more question from Kunal. He's working on his startup, and his question is, I want to build my career as a data analyst. Uh, can you please guide me? What's the best tool to start with? Power BI or Tabula, which is more better?
Okay. So I think, see, if there are two, three ways to look at it. If the focus is more about data analyst, data analysis, data visualization, understanding statistics, understanding data visualization concepts and principles are the first step I would recommend. Then second, of course, to start getting familiar with some of the open source tools plus Power BI or Tableau, whatever you can, based on your time, that you can try. But understanding the core methods, the concepts on underneath is very important, because when I use Power BI or Tableau, I'm just using that tool, but the features and functionalities, the principles are very important as that process. So as a data analyst, yes, I think the core fundamental aspects are very important. What should be there in the dashboard? What should I perform? What is the visualization focus when I'm analyzing the data? What are the key things that I should do? Is it dashboard for a particular, what is the target audience that I'm looking for? What is the industry? What is that I'm trying to solve? What is the set of questions that my dashboard or insights or visualization is trying to answer? These are some of the things I think are very important for us to learn in the process. Then automatically everything else will fall in place.
Thank you. So there is one more question from Rishabh Kumar. He's working in another technical company, confidential again. So what are the small and wide data which will replace big data?
So yeah, I think it's there everywhere. Small and wide data, it's just that, different way of representation from different analyst forums, organizations, and all. But I would say, if you look at, not every time we look at a lot of or large volumes of data all the time. Even if there are 100,000 records, sometimes what we do is going back and forth with the SMEs, going back and forth with some of the business subject matter experts, further reduce that to 20%, 30% of that, and analyze on top of it. So what it's reflecting is the fact that whatever data is needed for business purpose, business analysis, and essentially the business KPIs or metrics analysis is important for us to focus on, right? If we do that, then that's about it. We don't even need large volume of data or different types of data. But at the same point of time, when we look at certain cases, it depends on the use case by use case, where what type of data is needed. Now, if you're looking at large e-commerce players and there are huge volumes of data set or user based analysis, which is a huge amount of user space, and then their social media analysis of that data, that cannot be small. That always is going to be large, because our analysis would be better if we start looking at the whole proportion of the data and varied geographies, user base that we are analyzing on. On the wide data part of it is very important in some of the cases where we are trying to link many different angles or formats of data, because we spoke about not just the tabular format, but also coming from audio, video, weather data, and things like that. For example, weather data, right? If you look at data center optimizations, those kind of problems, and we are talking about servers, networks, and other stuff. The weather data also is very, very important in that case. Some of the farm agriculture, precision farming related use cases, there also you'd see the value of humidity, temperature, and the entire weather forecast data is adding a lot into there. So in some of those use cases, probably the wide data where there is a different format and linkage between this multiple data sources are relevant. I feel that's much more relevant in today's context, because we are expecting data from different sources, different disparate sources, and different data formats. And that's what this is nothing but the wide data is what we are talking about.
Thank you, sir. I have two questions, like personally for you, like related to your experience and all. So, like the first question is, having this much 23 years of experience and everything, going through the corporate
So,
part.
sorry, your voice was breaking. Could you please be
Okay.
louder?
Okay. I'm audible to you now.
Yes, that is
Okay.
correct.
So my question is, like, having such a great experience of 23 years plus experience, and having a corporate plus entrepreneurial experience. So how you describe that now, starting your own venture and like putting our knowledge over there. So like, what's the difference? Like I just want to understand the difference. As I am the community manager as well working in the company, I'm very keen towards the new startup things. So I
Okay.
have registered my own companies and like other things as well, but still learning. So like, what are the strategies like you like how we can implement all those things as well?
Very nice. So I think one, a very important aspect is the self belief and then the passion, that area on which that we are focusing on. Because I feel if we are focusing on something with passion, then we would not get stressed and we'll enjoy. And then that enjoyment is very, very, very huge aspect, though it's a small word. But how do we look into certain things that we enjoy doing it, so that we can achieve better in life? That's one core theme that has to be looked into. Second aspect is, when unless until we have an experience of some of the industries, some of the problems that we are solving, we need to understand the target audience. We need to understand what we are doing and how it will add value to the business, to the end result. Is it for a B2B? Is it for a B2C? Or whatever type of business model that we look into? It's very important to understand how it adds value, and then we'll have to strategize our focus towards that. And then the question again to that arises is, how can you do that? If you have gone through some of the understanding of that particular field, then creating solutions, creating products to cater to those type of needs would be much effective. So that is the second thing. And then third, about very point based solutions, very focused solutions that will automatically differentiate in the market. Obviously everybody, as we know, it's very difficult term to say how can you differentiate in the marketplace. It's very easy to say, but it's the most difficult aspect to do it. But I think it's not that difficult if we know what we are good at, and then what we have passion in, and then we can cater to building something where we are looking for that niche. So if we look at a combination of all of that, then definitely the differentiation will automatically come. And we should always have that, as we have seen in the industry, the customer 360 focus, 360-degree view of focus. So that's where it should propagate to.
Thank you, sir. Just one last question again from my end. From your end, from your experience part of thing, I just ask like, what are current scenario that's going on in outside market, as everybody aware about. So should students should adapt by while seeing all those things? A question related to students, I'm saying, still they believe like this data science, I'll be the machine learning expert. It's a hot cake they want to eat, but the process and all and the hard work as per my experience, they really don't want to proceed further, like with the all hard work that all our senior people done already. So like how they mold, what should they follow, like to be eligible, how they make themselves eligible to get themselves higher in a good placement drive or like a good placement company. So just one question for students.
Sure, sure, absolutely. So I think it's very important, as like the way I was mentioning about, if we start building a very step-by-step approach, structured approach on certain things, automatically things will evolve. Now, this cannot happen over 1 day or 1 month kind of thing, right? I mean, the key to that is when we look at this entire journey, obviously, data science is not something that I can learn in 1 year. It takes times to build that understanding and then different aspects of it. But what we can do as a student, when we are in that, is can we get some opportunities to learn new things. Now that I can do it by interacting in the community, but by going to Kaggle or some of the similar platforms and try with some examples, try to learn based on that. And that's one aspect. Second is, how am I building that visibility in the entire community? Because in data science, visibility in the data science fraternity, data science community is very important. Does not matter whether I'm 0 years of experience, 20 years of experience, or whatever. I may be, focusing on certain things which may be very specific, and I can add value, and people would look at it in a different aspect based on my experience and context. So community visibility is very important. Number two, if we are getting some opportunities in our second year, third year, up to the final year, the internship opportunities, those are, I think, very, very critical. Though we sometimes take it at a very, very light manner, but I think those are some of those 1 or 2 months or 2.5 months in some of the cases where we try to get an exposure to the industry or some kind of a practical real life use case solving kind of a scenario. We may not get a complete problem to solve within 1 month, but at least the exposure, interaction, culture that I get uh, exposure on, that adds a lot of value. And then, the more and more that you can do, that would be much better. That's number two. Number three, in you are anyways into a platform where you are also encouraging, kind of hackathons. Now currently, there's a lot of focus on competition based coding. The intent is not about getting a higher accuracy, getting a best solution at all. The approach to it, if we are building something, can we articulate and present to somebody, this is my approach. It may be 30% accurate or 50% accurate, and that's okay. But am I looking at a problem solving in a much different manner compared to others, right? So these aspects are very important. And then fourth point also is about the industry use cases. We never look into that. Nobody is stopping us to go and spend some time on Google and searching Gartner reports, some reports related to Forrester, IDC, HFS research. A lot of these things are there. Do we do that? We don't do that. We always focus a lot on Python or SQL. Those are all important. I'm not saying those are not important, but reading a little bit around this also helps a lot. And then fifth, getting our back to basics, right? B2B back to basics, getting our fundamentals really strong, where the SQL may be extremely simpler to look into, but SQL is you look at some of the large organizations, the technological giants, and then they have simple, one of the coding round would be focusing on SQL, right? I mean, it's as simple as that. So which means there's a lot of focus has to be on this, the core foundational aspects of SQL, then your statistics, probability, linear algebra, things like that. This will give a lot of boost to our overall data science understanding, and automatically get into that drive of doing things. So it's all a combination of, I think, a community presence that we slowly build towards, then learn from this fundamental core aspects, then also try to see if we can participate on some of the internships or some of the forums where there are competition based coding or things like that, options or hackathons. And then, of course, the industry use cases, some amount of understanding. So based on whatever, of course, we have 24 hours. We don't have more than that in a day. But we have to be really specific, because if I'm picking up and I have a passion towards getting onto computer vision, then I try to get onto some of the courses, some of the understanding towards that. I know a holistic view of everything, but I have a focused area of looking into one or two areas where I can specialize. So, for example, see, the best example is machine learning, right? I mean, you look at classification, regression, clustering, a lot of these things. I cannot really go deeper into everything, but it's always better, if you say yes, I know holistically how things work, but then you ask me anything on random forest, I'll be able to explain. You ask me anything on XGBoost, I'll be able to explain. That should be the approach we have. At least one or two algorithms to start off with, and going deeper into it. That's the core. And at a student level, I think one should be really clear about your passion. Are you going to look into the roles? What type of roles? Is it more about data analyst kind of roles, where there's a lot of data visualization, data analyst, data wrangling? That ideally is the first step, because I do a lot of things there, and then start learning, moving on to the phase. The growth of the phases is very important. So that's one way to look into it. Second way would be more about a data engineer kind of thing. Third way would be more about data visualization experts. Fourth could be into the research interns, that's kind of a role and all. It depends on what our focus area is, what type of organizations that we are also looking at, whether it is product-based organization, services-based organization, or consulting-based organization. And accordingly, we'll have to play our role that way.
Thank you so much, sir, for sharing your knowledge. So I think we are not having more questions. So I'll not take more time of anyone. So just for again, I have shared the link with everyone for our current competition that is going on, Twitter Viral Prediction Challenge. Plus, every student, if you have any problem or related to any questions, queries related to the session, or joining the BitGut community, so I'm available on LinkedIn. You can send me the request, and of course, I'm available for any guidance that you need. And additional information that I would like to share, we are currently hosting an campus ambassador program all over the world, where we got 160 participations, but we are expecting more. The date of that is like till 11th of July. You can join as a campus ambassador. You will represent your college, and after that there will be some task, of course, but it's an incentivized campus ambassador program. So one task equals to $100, one task equals to $150. So like this, we have made the program incentivized, because as we are not very much doing a physical events, that's why online, if you perform and you'll earn. So thank you very much everyone for being a great audience. Thank you very much, Mr. Kamal Mishra, to joining and
Thank you.
providing your guidance to us. Hope we'll connect again for some wonderful physical session.
Thank you.
Thank you, everyone. Thank you, sir.
Have a good weekend. Bye bye.